Calcite is a carbonate mineral and the most stable polymorph of calcium carbonate. The other polymorphs are the minerals Aragonite and vaterite. Aragonite will change to calcite at 380 470 AA degrees Celsius, and vaterite is even less stable. Properties: calcite crystals are trigonal rhombohedral, though actual calcite rhombohedra are rare as natural crystals. However, they show a remarkable variety of habits including acute to obtuse rhombohedra, tabular forms, prisms, or various scullenohedra. Calcite exhibits several twinning types adding to the variety of observed forms. It may occur as fibrous, granular, lamellar, or compact. Cleavage is usually in three directions parallel to the rhombohedron form. Its fracture is conchoidal, but difficult to obtain. It has a defining Mohs hardness of 3, a specific gravity of 2.71, and its luster is vitreous in crystallized varieties. Color is white or none, though shades of gray, red, orange, yellow, green, blue, violet, brown, or even black can occur when the mineral is charged with impurities. Calcite is transparent to opaque and may occasionally show phosphorescence or fluorescence. A transparent variety called Iceland spar is used for optical purposes. Acute scullenohedral crystals are sometimes referred to as dogtooth spar while the rhombohedral form is sometimes referred to as nailhead spar. Single calcite crystals display an optical property called birefringence. This strong birefringence causes objects viewed through a clear piece of calcite to appear doubled. The birefringent effect was first described by the Danish scientist Rasmus Bartholin in 1669. At a wavelength of 590 nm, calcite has ordinary and extraordinary refractive indices of 1.658 and 1.486, respectively. Between 190 and 1700 nm, the ordinary refractive index varies roughly between 1.9 and 1.5, while the extraordinary refractive index varies between 1.6 and 1.4. Calcite, like most carbonates, will dissolve with most forms of acid. Calcite can be either dissolved by groundwater or precipitated by groundwater, depending on several factors including the water temperature, pH, and dissolved ion concentrations. Although calcite is fairly insoluble in cold water, acidity can cause dissolution of calcite and release of carbon dioxide gas. Ambient carbon dioxide, due to its acidity, has a slight solubilizing effect on calcite. Calcite exhibits an unusual characteristic called retrograde solubility, in which it becomes less soluble in water as the temperature increases. When conditions are right for precipitation, calcite forms mineral coatings that cement the existing rock grains together, or it can fill fractures. When conditions are right for dissolution, the removal of calcite can dramatically increase the porosity and permeability of the rock, and if it continues for a long period of time may result in the formation of caves. On a landscape scale, continued dissolution of calcium carbonate-rich rocks can lead to the expansion and eventual collapse of cave systems, resulting in various forms of karst topography. Use and applications: high-grade optical calcite was used in World War II for gun sights, specifically in bomb sights and anti-aircraft weaponry. Also, experiments have been conducted to use calcite for a cloak of invisibility. Microbiologically precipitated calcite has a wide range of applications, such as soil remediation, soil stabilization and concrete repair. Natural occurrence: the largest documented single crystals of calcite originated from Iceland, measured 7A, 7A, 2M and 6A, 6A, 3M and weighed about 250 tons. Calcite is a common constituent of sedimentary rocks, limestone in particular, much of which is formed from the shells of dead marine organisms. Approximately 10% of sedimentary rock is limestone. Calcite is the primary mineral in metamorphic marble. It also occurs as a vein mineral in deposits from hot springs, and it occurs in caverns as stalactites and stalagmites. Lublinite is a fibrous, efflorescent form of calcite. Calcite may also be found in volcanic or mantle-derived rocks such as carbonatites, kimberlites, or rarely in peridotites. Calcite is often the primary constituent of the shells of marine organisms, For example, plankton, the hard parts of red algae, some sponges, brachiopods, echinoderms, some serpulids, most bryozoa, and parts of the shells of some bivalves. Calcite is found in spectacular form in the Snowy River Cave of New Mexico as mentioned above, where microorganisms are credited with natural formations. Trilobites, which became extinct 250 million years ago, had unique compound eyes that used clear calcite crystals to form the lenses. Formation processes: calcite forms from a poorly ordered precursor. The crystallization process occurs in two stages. Firstly, the ACC nanoparticles rapidly dehydrate and crystallize to form individual particles of vaterite. Secondly, the vaterite transforms to calcite via a dissolution and reprecipitation mechanism with the reaction rate controlled by the surface area of calcite. The second stage of the reaction is approximately 10 times slower than the IRST. However, the crystallization of calcite has been observed to be dependent on the starting pH and presence of Mg in solution. A neutral starting pH during mixing promotes the direct transformation of ACC into calcite. Conversely, when ACC forms in a solution that starts with a basic initial pH, the transformation to calcite occurs via metastable vaterite, which forms via a spherulitic growth mechanism. In a second stage, this vaterite transforms to calcite via a surface-controlled dissolution and recrystallization mechanism. Mg has a noteworthy effect on both the stability of ACC and its transformation to crystalline Ca-CO3, resulting in the formation of calcite directly from ACC, as this ion unstabilizes the structure of vaterite. In Earth history, calcite seas existed in Earth history when the primary inorganic precipitate of calcium carbonate in marine waters was low magnesium calcite, as opposed to the aragonite and high magnesium calcite precipitated today. Calcite seas alternated with aragonite seas over the Phanerozoic, being most prominent in the Ordovician and Jurassic. Lineages evolved to use whichever morph of calcium carbonate was favorable in the ocean at the time they became mineralized, and retained this mineralogy for the remainder of their evolutionary history. Petrographic evidence for these calcite sea conditions consists of calcitic oods, LMC cements, hard rounds, and rapid early sea floor aragonite dissolution. The evolution of marine organisms with calcium carbonate shells may have been affected by the calcite and aragonite sea cycle. Gallery. See also, Iceland spar, Icate. Ca-CO3 6 hours 20, list of minerals, lysocline, mangano and calcite, CO3, monhydrocalcite, Ca-CO3H2O, ocean acidification, ulexite also known as TV rock, another mineral with an optical property often illustrated in the same way. Your marble, references. Further reading, Schmittner Carl Eric and Jares Pierre, 1999. Microenvironmental controls on biomineralization, superficial processes of apatite and calcite precipitation in quaternary soils, Roussillon, France. Sedimentology 46/3, 463 €476. External links, calcite information and images.